who, what, when, where, why, and let's start with the chronological order of things. First, living architecture, turning trash and recycling into structures and infrastructure that can grow food out of the walls, and medicine, any of our other crops. So this is a way to take the power back. Very, very few people own most of the money, and we need money to eat, to sleep well, to get water, to get medicine. All of that can change if we use mycelium to form living architectural elements that can support an ecosystem and that are symbiotic with all of our crops. This will require a water infrastructure, and this will require mycelium and trash, and that's all. That's all you need to do this. That and like some elbow grease, community effort. But I hope this year with my laboratory at Living Architecture Lab, at Myco Architect on YouTube, and y también Bioedificios in YouTube, I hope to provide easily replicable methodology that works in whatever ecology, whatever, climate, community, something that makes sense for your area. I live in the Coachella Valley, and I've been thinking a lot about insectoid exoskeletal respiration, which is a static architecture, not an in and out breathing. So this is basically God's version of a mobile mycelial protector. This is like a grow bin. This is a lot like a grow bin that you would buy online to grow mushrooms in. It's, seriously, I'm talking about an ant exoskeleton is very similar to a grow bin for mushrooms that you would buy on Amazon. So, we can take that form, blow it up, make it really big, and turn it into a house for you that's made out of trash and grows food. And then I hope to retool that, or I hope someone does, to create ants, because I think I have a really elegant solution to how to compute the form of a mine or a structure, or how to really all the computation involved in like a self-replicating robotic hive that mines and myceliates a landfill and forms living architecture. I think a lot of this computation, a lot of the computation required to do something like that can be done by real ants. So the way we do that is we send out sensors throughout the landfill, collect data from it everywhere, and also materials, and we create all these scaled to ants, but exactly proportionate, like we're doing it miniatures for a movie, like Star Wars. We create these materially and structurally representative little microcosms, dioramas, miniatures of the landfill, made just the same way the landfill was practically. And then we introduce ants to them, but we've replaced the parts that we are interested in with food, so that they carve a path directly to it. And all we have to do is make ant-shaped robots, base our robots off of these ants, and then program them to do exactly what the ants did, and our robots will do something useful. They'll go get the thing that is needed. If there's a deposit of plastic and cardboard somewhere in there, that's what our robots need, because they have a plastic carapace, they have a plastic exoskeleton, and on the inside of that is myceliating cardboard, and other stuff, and trees can grow in that. It's hyper symbiotic with all of your crops. So mycelium is the body of the fungus. It's super symbiotic, and it ties together trash into a single thing. I've been talking about it like it's very similar to snow, which is why I want to make igloos with this. This living architecture, and then robotics, living robotics, mining landfills. Ghana has landfills that are full of cotton. They're full of textiles. Let me say it again. Ghana has landfills that are full of textiles. Okay? Mycelium loves textiles. That's great for wrapping up the mycelial colony, but it can also eat it. But it's great for wrapping up the mycelial colony because they can breathe through it, but they can also eat it. And it's nutritious. So we can use this Obrani Wawu, they call it, dead white man's clothes in Ghana. These landfills that have been eroding to fill river systems, wash up on beaches. We can mine those landfills with our hypersymbiotic mechs. Our machine hive can use those and mine them and then collect them. And then step 3, colossal biomimetics, massive biomimicry. They create a pipeline. Basically, they bring these textiles. They bring these textiles from the landfill to the river, where they wrap up water bottles really tightly and send these flotation devices down the river, where they all bundle up, and they're packed with a bunch of other things and fit into a shape that makes sense, sort of like a big myceliating maybe, but full of mangroves and seagrasses and all kinds of plants. This big floating structure, like an iceberg, that, and we make a big chain of these things. These big green iceberg flotation devices. And they're enormous, like the size of a building. I say iceberg-sized, iceberg-shaped. Bundles of floating plastic, flotation device, totally rooted, wrapped up and rooted. So protected from the sun and protected from friction, does not turn into microplastics. This flotation device can not only enrich the ecosystem and will transform into like a habitat, but it will support an underwater hanging garden. And if you have a chain of these things together, each hanging a garden underwater, which is growing on, guess what, textiles. And this is all woven together into this big, thick thing that, a cell, a bowl, a basket. This is cellular biomimicry. Silty freshwater enters the first cell, or the first cells that are in the river mouth. And that silty fresh water goes from cell to cell to cell, fills the whole chain. Each cell is a ring of these building-sized plastic iceberg mangrove things that hang a garden, and it's all tied together into a cell that fills with fresh water and silt and goes from cell to cell. There's a big chain of them, miles long, and it stretches way out into the sea. So this is a part of the sea that is freshwater and nutritious. The sea is a saltwater desert, so this is an extraordinary thing to do. And each river has a plume, and to do this would require like 5 or 10% of that freshwater plume as it enters the sea. But it would not just double, I think far more than double the nutritional output of that river into the sea. It's like stretching that plume indefinitely. You will be pouring silt miles and miles and miles offshore. You're still pouring silt. and fresh water, and you have this estuary system that is just like stretching like across the entire ocean, aerosolizing so much silt. The whole world is enriched by it, not just the Amazon. Okay, so we have living architecture, living robotics, colossal biomimetics, and I touched on DNA like spiral, helix, living architecture, filaments, giant ones extending into the sky in this helix shape, stabilized by an orbital tether. I talked about passive volcanic eco-architectural megalithic output, forming dome structures, fractal structures, upside down root type structures, fractal piping for hot steam, expand the atmosphere, maybe even over millions of years, grow an object that is kind of, at the upper reaches of this tree, where actually the leaves are entire trees, so it's a big black green forest. The upper reaches of this thing, there's lower gravity. And I talked about, these colossal biomimetic cells. These cellular biomimetics can green the Sahara without annihilating the Amazon. And we would do that using Obrani Wawu textile hanging gardens from mangrove buoys the size of buildings. And I am restating a lot of this. I'm just... what else? Living worlds. So, your heart is very much like a conch shell. It's a pump, it's a spiral, it's a ribbon. You can unravel it. Don't look it up unless, it's kind of gross. But you could make a satellite or spaceship. You could make a moon in this shape. And if you stuff the entrance to it with prisms that, face toward your light source, your star, whatever floating bright orb you have somewhere in the solar system, then it's going to refract, spiral like, rainbows on the inside of this thing as it spins rapidly. So that is a potential living world, a biosphere that would, I think, support life very well. And if you filled our solar system with big bright orbs and living forms, biomimetic structures, and you went really, really fast, I think those orbs, that light, those light sources that you spread throughout the solar system, as you zip from one side to the other as fast as your little spacecraft can go, I think those lights might actually streak past your windshield, just like Star Wars. And and if you made these living worlds so that they could shift their internal mass rapidly, high G maneuvers, I think that by doing this, they could manipulate their external gravity, or at least manipulate gravity in the way that you want. So there might be a way of negotiating with these living worlds to actually do something like the Force. So in this way, George Lucas's work is like not as crazy. I think, this is crazy, of course, crazy cool, but it's not crazy like that's impossible. And just the fact that I can't picture exactly what the planet would have to do, what an object that has gravity, you know, that has enough mass that it has a gravitational field, what that thing would have to do or be within itself in order to manipulate gravity in a very specific way to do things like the Force in Star Wars. Just because I can't understand that technology doesn't mean it's impossible.